Here we go. Need a little help from number 13. Okay, first of all, I have a couple questions. Pentagon, how many sides? 5 sides. Regular tells me all the same length. Here is one side from -1, 4 up to 2, 3. -1, 4 to 2, 3. How do I find the length of that one? Distance formula. D equals big square root. What were your x coordinates?
I did 2 plus 1 squared.
Everyone's, hold on, 2 plus 1 because it's 2 minus a -1. That's where she's getting the 2 plus 1 from. Squared plus, and then what about the y coordinates? 3 minus 4 squared. And what did you get underneath the radical? 10. Yep. So that's one side. There's 5 sides. They're all congruent. So what'd you do with the 10, Maddie? And got 5 radical 10. Anybody have any flashbacks while you're doing that problem? Anybody seen that one before? Where you seen that problem before? Midterm, yes, it was on the midterm. Yeah. Also an old Regents question. So, all right, here we go. Next one. I thought this one was probably the toughest one of all the days because it was very easy to set it up incorrectly. Very easy to set it up incorrectly. All right, let's see what you got, Ted. Just setup first. Setup. I like that way a lot. Setting it up as a ratio or a proportion first, because I don't know how many of you put 2 times 3 times x minus 1. Hey, think about this. Which triangle? If it's 1 to 2, which one's bigger? GR 1 to 2. 1 to 2. Which one's bigger? GRL. Everyone agrees? Which would mean which one's bigger, BO or GR? GR. So I wouldn't multiply GR by 2. I'm making it even bigger. All right. I would multiply the smaller one by 2 to set it equal to 3x minus 1. All right. So not out of the woods yet, though. I don't know if some of you read the problem all the way, because once you found x, great job. That wasn't the one we were looking for, though. What'd you get? 2x or x equals 7? But I was looking for GR, so plug in 7 to GR. And what'd you end up with? 20. Yep. Any issues there? So first week of Regents Review problems, not too bad. I'm not trying to hammer you here. I just want you to try a couple a week. Any questions? Okay. Let me go now to the packet work, please. The packet work of your 30, 60, and 90 triangles, and 45, 45, 90. I believe you had 4 questions in the packet. 4 or 5? 4? Any of those 4 give you problems? Please ask as many questions as you can. Today is going to be the second day of this. The only change is the algebra with the radicals will get a little tougher. So let's start off, Letty. Okay, so for 4, RT or RS. All right, I think I still have this up here. So. Okay, just keep those up there. All right, we were told that's radical 3. That's in my, and this is going out to everyone. All right, just because Letty asked it here, I'm going to ask a bunch of questions to everyone. So I'm given radical 3. The radical 3 is part of what type of special right triangle? Here we go. 16. The radical 3 is part of what special right triangle?
30.
And where's the radical 3 across from, Zach? What angle measure?
30.
It's across from the 30. So I'm going to put the radical 3 right there. Let's fill in the rest of this 30, 60, 90. Fill in the rest of the chart for me. Here we go. 4. What do I do to the 30 to get to the 60? Multiply it by? And if you multiply a radical by itself, the number underneath, which is 3. Okay, Maeve, name the side. Name the segment that's across from the 60 in that diagram.
ST.
ST. So that's going to be ST. I'm working my way to your question, Letty. All right, but I got to find these values first. All right, so ST, 3. What about the side across from 90 now? What do I have to do? 14. What do I have to do to the side across, get to the side across from 90?
So you have to plug in the radical 3. So you have to multiply 2 times radical 3. So it'll be 2 radical
2 radical 3. Name the segment that's 2 radical 3 in that diagram.
SP.
SP. Everyone all good so far in the 30, 60, 90? Okay, now the 45, 45, 90, which is the entire triangle, RST. What's one side we already know in that triangle, RST? Here we go, 13?
No,
ST, which is 3. And what angle is it across from in that 45, 45, 90? Okay, so that's going to be 3. What about the rest of the diagram? Rest of the chart, help me fill it in. Here you go, 3. What's across from the other 45? 3. Name that side. I already know this side's 3. What's the other side across from the 45? RT. So there you go. One answer there, Letty. RT is also 3. And then what about the final side across from the 91? 3 radical 2. Name that side, Andrew. RS. Yep. Questions, Letty?
Yes. So I put 15 there, but I didn't, like for RSP, but I didn't think that that was right because I didn't.
No, that's 15. You're correct. But this triangle right, RPS, this triangle right here, that's not a special triangle. We were just working with RTS, which is a 45. Add them together, you get 45, 90. Okay? Anything else from the packet? Anything else from the packet? All right, while we're in the packet, I need you to add something for tonight's homework. So if you go to the packet and go to page 17 for me and look at diagram number 5. Page 17, number 5. That problem right now is impossible to do unless I add a degree measure into it. Everyone ready? DCE, 45 degrees tonight. DCE, 45 degrees. All right, that problem's impossible without it. Okay, DCE, 45 degrees. Then you had a couple problems from the book. Anything I can answer from the book, especially if it's like a radical equation, like a radical question on how do I deal with this radical. Yes, Maeve.
Number 10, how did you get 34?
How did I get 34? Great question. It's a 45, 45, 90. You see how this 17 radical 2 is across from the 45. I won't put the chart up, but what do I do with that side to get to the hypotenuse? I multiply it by? Yep. So I'm going to take 17 radical 2 and multiply it by radical 2. Here's what's happening. I know many of you just plug it into your calculators and probably got 34, but here's what's happening. 17 I can't multiply by anything. But what happens when I multiply the radical 2 and radical 2? You just get 2. 17 times 2. That's where that 34 came from. Yes, Maddie.
Number 12, so it is okay to have 19.5 radical.
Or you could have had, what?
27.6.
No, I don't want decimals, no, if that's what you're asking. I was just going to say you can have 19.5 as a fraction if you want instead.
Okay.
That's fine. 20, I don't know. I'm not even going to bother. What, 41 over 2. Nope. This is, I'm not going to let this down now. Because 40 divided by 2, 39 divided by 2, radical 2 if you wanted to, but no decimals, no decimals. Anything else we wanted to ask here? Are we, how, Zach?
Can I just see number 20? I think that might have been. I'm pretty sure.
Number 20?
Yeah.
What do you mean you're sure you got it wrong? I put an answer key up on Aspen for a reason.
No, I looked at it. I was just.
And if this doesn't pop up,
Oh.
of course it wouldn't. Why would it?
Right. Yeah, I think I can figure it out.
Well, it's not popping up, so.
Yeah, I think I.
Do you have a diagram in front of you, or?
No,
Hey!
Oh.
Okay, go ahead.
Oh yeah.
That's 15.
Uh-huh.
That's the side across. That's the side across from 90.
Yeah.
So if you wanted to go backwards, the side across from 30 would be 15 divided by 2, 7.5.
Yeah.
Okay, good. Or 15 over 2, whatever. And then what do I do to that side to get to the side across from 60? I multiply 7.5 by radical 3. So instead of 7.5 radical 3, I think maybe on the answer key I had 15 over 2 instead. That's fine. All right. Anything else? Okay, can I see it, please? And then I only have 3 questions with 30, 60, 90 for you today. Again, nothing's going to change except for you might be a little hazy on how to deal with the radicals from algebra last year. All right, number 1, no big deal. It's a 30, 60, 90, so let's get our rules out. Need somebody to remind me what those rules are in the 30, 60, 90. 13, remind me of the rules.
X radical 2,
Oh,
3.
rookie mistake.
What?
X radical 3. The radical 2 belongs with the 45, 45, remember. And then under 90?
2x.
2x. All right, here you go. I gave you the diagram. What's the 12 across from? 9. What's the 12 across from?
60.
60. And I need to get to the side across from 90. Yikes. You look at x radical 3, the 2x. Guys, I have no idea how to get there. I have no idea what to do to 12 to get to 90. But you know what I do know? I do know what to do to the 30 to get to 90. So even though it's not being asked, I'm going to find the side across from 30 so I can double that bad boy to get to the side across from 90. That's the tough part today, is going to the left, going backwards in your chart. How do I go from 30 to 60? How do I go from the 30 to the 60? Multiply by radical 3. So if I'm going backwards to the left, I want to divide by radical 3. Get those calculators out. I do no. I meant don't use them. I don't want sloppy decimals. All right? Don't even think about it. Get them out of here. All right. Everyone's coming from almost different places last year. I'm hoping one thing you learned or remembered from last year, no radicals in the denominator. Okay? Maybe some of you don't know that, but I'm telling you now. No radicals in the denominator. Anybody remember the process to get it out of the denominator? You multiply top, numerator, and denominator by the radical you want to get out of there. So I'm going to multiply top and bottom by radical 3. So you guys know what allows me to do that? What is radical 3 divided by radical 3? 1, so I'm not changing this at all by multiplying it by 1. Right, I'm not changing the value. Okay, why do I want to do this? Well, here we go. Numerator times numerator, 12 times radical 3. 12 radical 3, nothing, can't do anything there. But on the bottom, we've been here already, this unit, radical 3 times itself. No more radical. Simplify, keep going. We're not done yet. Keep simplifying, can't touch the radical. 4 radical 3. There you go. So the side across from the 30 is going to be 4 radical 3. Which now makes my life easier because what do I do with the 4 radical 3 to get to the side across from 90? What am I going to do here? 13 again, on fire. Multiply it by 2, so 4 radical 3 times 2. 8 radical 3 for the side across from 90. Yes, Grace, go ahead.
I like understand it.
Yep.
But I'm just like, why wouldn't instead of having 4 radical 3, it would be like 4 and then radical 3, like 4 times radical 3 over 3.
If there's a plus sign or a minus sign, yes. Because you're thinking about like quadratic formula. Yeah, if there's a plus or a minus sign between the 12 and the radical 3, you are 100% correct. All right. Any questions from you guys? Going? Okay, not a big deal. It's just some radical algebra. All right, AB is 2. What's the length of BC? Oh. Well, it looks like I got a 30-60 going on, right? And a 45-45 going on. Here's my first question. Triangle ABC. Is that one of the special ones? Triangle ABC. Yes, no? No, and I asked that because we're not going to go right from 2 to BC now. I got to find some sides in between. Because this triangle ABC is not a special one, I don't know any rules, so I cannot just go from 2 to X right away. I got to find some sides in between. So 2 is a part of what special triangle, though? 45, 45, 90. So we'll deal with that first. Where's it across from in that 45, 45, 90? 1, where's it across from? The 90, yep. Oh, I almost made a mistake there. Nope, 2. So it's across from the 90. So the only thing I could find is the sides across from the 45s, right? How am I going to the left? Backwards. What am I doing with the 2? Not multiplying it by radical 2, but yes, dividing it by radical 2. What we just talked about in problem 1, no radicals in the denominator. So what do you want to multiply numerator and denominator by here? Top and bottom by? Radical 2, yep. All right, let's hear from somebody here. Number 12, what's on top now?
2 radical 2.
And on the bottom?
2
Yep. Simplify anything for me there?
radical 2.
Just radical 2, yep. So the sides across from the 45s are radical 2. Perfect. Now what do I turn my attention to? What type of triangle now? Go over to the right. BDC, 30, 60, 90 now. X radical 3 and 2x. What side do you guys know in that 30, 60, 90? What side do you know? 20? What side do we know? The side across from 30 is radical 3. Yep. Radical 2. And I'm looking for the side across from 90. So what do I do with that radical 2? I was on 7. There we go.
Multiply by 2.
Multiply it by 2. So what's the side across from 90?
2 radical 2.
2 radical 2. Are we okay switching from one triangle to the other? And Letty, go ahead.
In a on a test or something, if it just asked for 90 and we didn't have to find one of the sides, would that be and we didn't find it, would that be?
Yeah, like I didn't find I didn't need DC, so I'm not even going to talk about it. Bella.
If we were asked to find the side across from 60,
Yep.
What would we do to radical 2?
Okay, well, let's see what the rule is, right? I multiply it by?
Radical 3.
So radical 2 times radical 3. You are multiplying, so you can combine any radicals you want. So that'd be radical 6. Okay, good question, radical 6. And then I had to get in a little review concept here with our quadrilateral unit, rectangles. Anybody want to tell me anything about angle C, if it's a rectangle? It is a right angle, so that tells me I have a 30, 60, 90 here. Where's the 12 going? Where's that 12 going? Hey, 8, where's that 12 going?
Under the 90.
Yep. And you do have to find both the side across from 30 and 60 because it's asking for perimeter. So anybody want to help me out? The side across from 30 and 60? 9? Yeah.
The side across from 30 is 6.
Because I'm dividing by 2. Going to the left, dividing by 2. And what about the side across from 60?
6 radical 3.
Okay. So across from the 30 is 6. Across from the 60. What do you guys know about opposite sides of a rectangle? They are congruent. And then how do I go about finding a perimeter? Add up all, not 2 sides, add up all 4 sides in this case. Now I'm going to ask what can you combine and what cannot be touched. There's only some certain things that can be combined with each other up here. Here we go. 14, what can be combined?
The 6 and the 6.
Yep.
And then the 6 radical 3 and the 6 radical 3.
Okay, so 6 and the 6 give me 12. What about the 6 radical 3 and the 6 radical 3? 12 radical 3. Can you go any further? Go any further? No. But the directions, hold on. The directions do say nearest 10th. You can get your calculator out in a second. I just want you to realize that this is in simplest radical form. If the directions ever ask that, which it probably will. Simplest radical form. All right, but it does say nearest 10th. So if you want right now, go ahead, get those calcs out, find out what the perimeter is, and savor this moment because this is a rare moment I ask for nearest 10th or anything, decimal-wise. Like to keep our answers exact. And when you find it to the nearest 10th, let me know. 16.
Here's 10. 32.8.
Thank you. It knows, Zach. I don't know. It may say random in front, but it knows. It knows.
Never got my number called more than once today. Today's not a good day.
I don't know what to tell you. Other questions or comments? All right. You might as well get started on the 5 problems in the packet. And if you get done early, you can go to the book.